Hello, and welcome again to Math County. So, last time we spoke about the power rule and then the chain rule. But today, we are going to talk about the product rule, the quotient rule, and then the implicit differentiation. Okay, so let's start with the product rule. Alright, so we use the product rule when we have two functions multiplying each other. Mind you, so if you have two functions, f of x is equal to g of x times h of x, right? Given that g of x and h of x are differentiable. Then we can use the product rule. So the product rule simply says that if we have a function like this, then f prime of x is equal to g of x prime times h of x plus h of x prime times g of x. Let's look at an example. Say we have a function like f of x equals x e raised to the power x. So clearly we can see that these are two functions multiplying each other. We have this, then we have this. Okay, let h, so we can say let h of x be equal to x, and then let x, and then let g of x equal to e raised to the power x. Right? So to use the product rule, all we need to do is to find h prime of x and then g prime of x, right? So h prime of x is equal to 1, and then g prime of x is equal to e raised to the power x. We've gone through this already, right? Okay, so we have f prime of x equals, alright, what's g prime of x? So g prime of x is e raised to the power x, and then h of x, which is x, plus h prime of x, which is 1, times g of x, which is e raised to the power x. Therefore, we have f prime of x to be equal to e raised to the power x, x e raised to the power x, plus e raised to the power x. Right? Good. Alright, so let's look at this second example, which says that y is equal to x squared sin x. Again, we can let h of x be equal to x squared, and then g of x be equal to sin x. H prime of x will be equal to 2x, while g prime of x will be equal to cos x, per the derivative of trig functions we did earlier. So, to put them together, y prime will be equal to g prime of x. What's g prime of x? G prime of x is cos x, and then h is x squared, plus h prime of x, which is 2x, and then g prime of x, which is g of x, which is sin x. So at the end of the day, this will be the outcome: x squared cos x plus 2x sin x. So this is how the product rule works. Okay, let's look at how the quotient rule also works. So we have the quotient rule. All right, so for the quotient rule, we also use the quotient rule when the function involves two functions or two rational functions such that they are dividing each other. So we say if we have f of x is equal to g of x over h of x, then we can use the quotient rule. What does the quotient rule say? The quotient rule says f prime of x should be equal to h of x times g prime of x minus g of x times h prime of x all over h of x all squared. Okay, so let's look at an example. Example 1, we have given y equals x squared plus x minus 2 all over x cubed plus 6. Right, so we can let this be the same as g of x all over h of x. So what is g prime of x? G prime of x will give us 2x plus 1, while h prime of x gives us 3x squared. Yeah, 3x squared, right? Because if we differentiate the constant 6, we get 0. So we are just left with substituting it into the formula. So we have f prime of x equals, what is h of x? H of x is x cubed plus 6 times g prime of x. G prime of x is 2x plus 1 minus g of x. So what is g of x? Our g of x again is x squared plus x minus 2 times h prime of x. H prime of x is 3x squared. So we divide everything by h squared. What is h? H is x cubed plus 6 all squared. Okay, so all right, all squared. So we have this, and then we just need to simplify the numerator, and then say that the numerator is the same as saying minus. So I implore you to do the simplification, and then you will come by 2x cubed plus 6x squared plus 12x plus 6 all over x cubed plus 6 all squared. Right. Okay, so we can look at this other example, which is very simple, which is y equals t raised to the power 4 minus 1 all over t raised to the power 4 plus 1. Again, I'll leave this for you to solve, and then you can leave the answer in the comments section. Okay, so I'll move on to talk about implicit differentiation. So when do we use implicit differentiation? We use implicit differentiation implicit differentiation when the function is not explicitly stated that y is a function of x, or when the function cannot easily be arranged such that y is the subject. Okay, so let's take a look at this. So we have a function like x squared plus y squared equals 25. Okay, so what we need to do here is we can differentiate across the function by x. So we can find d dx of x squared plus d dx of y squared equals d dx of 25. Okay, and when we do this, obviously this gives us 2x plus 2y dy dx, okay, equals 0, since it's a constant, right? So we need to make dy dx the subject here and say that 2y dy dx is equal to minus 2x. So we divide both sides by 2y, and then we have dy dx is equal to what? Minus x over y. So this is implicit differentiation for you. Right? Let's look at this other simple example, which says that we have x e raised to the power y equals y sine x. Okay, again we differentiate both sides of the equality sign, and then here we employ the product rule, the same thing here, and then we are going to have e raised to the power y plus x e y dy dx equals dy dx sine x plus cos x. So we keep y constant, y cos x. Okay, the next thing is to group like terms and then make dy dx the subject. So we say x e raised to the power y dy dx minus sine x dy dx equals y cos x minus e raised to the power y. So dy dx comes out, and then we have x e raised to the power y minus sine x. So we divide both sides, and then we have x e raised to the power y minus sine x. Okay, so cancel this, and then we have dy dx is equal to y cos x minus e raised to the power y all over x e raised to the power y minus sine x. And this is our final answer. So I entreat you to take your time, pause the video as many times you can, go through it one after the other, try to produce the answers by yourselves, and you'll be fine. I'll see you again in the next video, where I talk about integration, and then we solve some examples under integrations too. See you again in the next video. Have a nice day.